Hey everybody, it's IoT Day today. It's April 9th. IoT Day is a pretty cool thing. It's something we've been doing every year, going back to 2010. A whole bunch of friends of mine and colleagues all around the world, kind of been supporting this for a long time. Usually it's a day I do some kind of crazy tweet storm, not for the whole 24 hours, but for a bit of it, just to keep it going. Just kind of that constant drumbeat every year of, what a great contribution IoT, Internet of Things technologies has made to the world. Um, so today we're gonna kind of take a different spin on it. Rather than talking about IoT or analytics technology or how you apply it to business, we're going to do something that's a little more important than all of that, is applying a lot of this IoT, Internet of Things, and digital twin technology to the problem of fighting this scourge called COVID-19, the coronavirus that's been going around the globe. Uh, it's been an awful thing. Lots of people are all at home. People are sick. People have not survived. Economies have shut down. And so it's all hands on deck. I certainly know about being all hands on deck from my days driving submarines in the Navy. And so we need to run towards the problem and solve it. And so, in my own way, everybody has their talents or things they know about, and how can they contribute to this? And so one of the things I've got is I know a whole lot about IoT and digital twins because I've designed and built some of the biggest systems in the world over the years. And so I'm happy to dive in and use skills I have to help out. Other people have different skills, and we need everybody. Absolutely. So I'm going to walk you through today is talking about how we're going to use this crazy thing called digital twins to fight COVID-19. To start out, I just want to spend a moment talking about the Moab Foundation. Those of you know me, you know me over the years, whether I was at Microsoft or building Lumada Hitachi. I work at Ericsson. I'm a VP. I head up our IoT data strategies there. And so we help things at Ericsson, as you can imagine. We make that connectivity possible, that cellular connectivity, whether it's 4G or as we're rolling out 5G with all our mobile operator partners around the world. It makes IoT possible. You've got to have a way to communicate, usually wirelessly, especially when you're out and about, right? We do things like connection management, connected vehicles, security, things like that, all these important capabilities. Back before I joined Ericsson, though, I'd been involved in different, panel discussions, writing, different events, where more and more I started to see how IoT, that remote sensing and knowledge, and applying, in many cases, simple analytics, sometimes more advanced things like machine learning, to make a difference, to move the needle in things like climate change, for instance. And so over time, I was like, you know what, I need to, at least I feel, how do I give back? How do I help the planet? So I started this nonprofit foundation to go after that. The United Nations Sustainable Development Goals is a great way to kind of categorize things. There's 17 of them. And so it gives you categories, whether you're talking about ending poverty or inequality or climate change or water issues, or health and well-being, things like that. So my idea in creating this Moab Foundation nonprofit was just two big things, really. Get folks, leaders around the world in technology, that folks that I'm friends with everywhere, and combine them with people who have a lot of expertise in those different categories of the Sustainable Development Goals, and start just coming up with use cases. I know use cases might seem like not the biggest thing. You're always thinking, oh, I got to have some incredible technology. I usually find technology is the easy part, actually. So those use cases, those scenarios, what are the individual things in all those sustainable development categories where Internet of Things, technologies, analytics, wireless, digital twins, those kind of things, where could they be applied appropriately to make a difference, to help out, to move the needle for folks? The other part was, to create a platform. Since I built some of the biggest platforms in the world and designed many of them, and I still know how to write code, crazy me. I decided to build an IoT platform that can run at the edge, run at any cloud. Those of you who know me, I'm big into digital twins. Building Lumada at Hitachi, we call them asset avatars because it's a heavily industrial type thing. Everything's an asset, as you can imagine. But I really, over time, learned about the power of digital twins over the years. And so I wanted to build something that could enable folks, but it's not to compete against anybody in the commercial space. It's for me to give away, but specifically it's to give away to NGOs, to nonprofits, to government agencies who are tackling these big problems around the sustainable development goals. I know that they don't have a lot of cash on hand. They're raising money. Sometimes they're charities. They're always strapped for cash, but they're doing the best work in the world. And I've also found over the years, you don't have to have the most advanced technology or the most advanced deep learning to really move the needle and make a difference in people's lives. And so kind of that's where my head was at. And so again, this is kind of a labor of love for me and friends and people I'm connected with around the world who share some of the same ideas. Something that, again, taking a talent and then giving it away to people to help them out. I think my earliest thoughts around that came from, if you remember Nicholas Negroponte from the United Nations, when he did the one laptop for a child thing, getting them into villages, in poor regions or countries, again, we're not having to give the best technology, but it turns out just giving something baseline type stuff can really make a difference in people's lives. And I think that's kind of what originally inspired me and realized that this could help out. So this is something I do on the weekends, and again, with a whole bunch of folks who care a lot. So let's dive into what we're going to talk about today. Session objectives and takeaways, So I'm going to talk about one sustainable development goal in particular that's obviously related to this whole COVID-19 issue that we're dealing with. I'm going to talk about how we represent people as digital twins. Usually you think of machines as digital twins, but I'm going to talk about how we can use it with people. And then how we can apply just simple rules, KPIs, and then do prescriptive, you've heard of, predictive maintenance. I'm going to talk about going beyond that and have prescriptive analytics and actions. You find out what's wrong, and then what to do about it, which is super important. I'm going to show you how people can be digital people, not only going to have a digital twin for the person, but how the person's going to be an IoT endpoint using their smartphone to send telemetry. And so in the end, the key takeaway here is I just want you to know how having proactive data, repeated, frequent proactive data coming instead of waiting till testing happens and being very reactive can make all the difference between containing this virus or the virus getting away from us, and we're always fighting to just try to mitigate it. We're behind the curve, right? So proactive versus reactive. All right, so let's dive in here. Good health and well-being is sustainable development goal number 3. Well, guess what? COVID-19 is right within the purview of SDG 3. It's about health and well-being. The documentation around this from the UN even really spells out things like ending epidemics like AIDS, tuberculosis, malaria, and other diseases by 2030. So this is right in the wheelhouse of this SDG. And so it makes perfect sense. It's great alignment there. I love data. Everything else is speculation, so whether I'm thinking about, lots of great quotes from Peter Drucker or Deming or things like that, if you don't have data, you can't manage things, right? If you can't measure it, you can't manage it, you can't improve it. And so when we don't have that data, we're flying blind. We have lots of anecdotal evidence, or we're getting data late. And so we're always kind of behind the 8 ball. So frequent data, proactive data is going to make all the difference. So we got to have that measurement to manage and to improve the situation, whether it's a normal IoT situation that you might be thinking about, or this COVID-19. And then I, in my mind, I was like, let's make digital twins of people and set the kind of the right properties. There's all kinds of, I've long talked about using digital twins of people as patients in a hospital, a person, kind of like a machine, and having subsystems like their heart and their lungs, and their brain, and things like that, and all the attributes and how we can use that to improve people's lives in a medical setting. So it's always been in my head I work on a board of a healthcare organization, and so we talk about that kind of stuff all the time. And so, it's laser focused on here and on how we can work with COVID-19. So I'm going to kind of talk about how we do that. So let's start off with digital twins. I'm going to kind of give you a crash course on digital twins. I'm going to kind of tell you little bits about them and just a few things, and then I'm going to dive into how we make it appropriate for this task that we have at hand. If you want more exhaustive talk on digital twins, because I'm not going to go really deep on them, I've got another session called The Anatomy of a Digital Twin. The IoT Slam folks are doing on the same day here on IoT Day. And so you can go check out those links, and I'll get that information out to folks as well, so you can have a deep dive. This will be more of a shallow dive. So digital twins, where do they come from? You probably recognize these guys here from the movie Apollo 13, right? Yeah, Houston, we have a problem. So easy definition of digital twin: it's a digital representation of a physical object. Usually that means a machine, oftentimes, or subsystems, but it can absolutely be a people. It could also be processes and stuff like that, but we're not going to go that deep. So digital twins kind of got their start back with NASA, back in the 60s. So NASA used mostly physical twins, but they did a little bit of digital stuff too. So if you saw Apollo 13, and they had all kinds of things going wrong up there in their spaceship, and now how do we get them back from the moon? And so you might remember, while they're up there troubleshooting back in Houston at Mission Control, you've got Gary Sinise, and he's working with a duplicate physical twin model of the spaceship. And, they're trying to, put square pegs into round holes, right? To get rid of CO2 and all kinds of other issues to bring systems back online, not using too much power to overload the system. All that kind of troubleshooting was done with physical twins and a little bit of digital. But it also made it clear how important digital twins would be to make it easier to do that kind of troubleshooting, to have that mirror image of the real thing, to solve problems, and ultimately to make products better in the future, actually. And so that's kind of where it got its start. It got another big boost in 2002, though, and I think that's when a lot of people think they really started to take off. Dr. Michael Greaves, he kind of talked about digital twins as part of, product lifecycle management. If you've ever heard of PLM, products that are from when they're designed, deployed, retired, that kind of thing. And so he talked about this thing called a double ganger. You kind of think of to take on doppelganger, but that's kind of what he was talking about. And that's kind of when the idea really started to sink in. And so from beginnings in NASA, digital twins really, really took hold, I'd say primarily in manufacturing. But they don't have to just belong in manufacturing. And I'm now seeing them move more broadly into different spaces, different domains. And I think the IoT megatrend and these IoT platforms has really helped make digital twins more accessible to people. You're seeing them a lot more. A lot of times they're really simple, but they're getting there. I personally think that the digital twin should be the underpinning of any IoT platform. It's the what of the system. Everything else is plumbing, right? When I was at Hitachi and I would talk to people about Lumada, I just would jokingly say, you know what, it's just a runtime for digital twins, for the avatars. They're what's important. And I still believe that today. So I'm going to talk to you about a few aspects of digital twins. I'll kind of give you short definitions, and then I'm going to dive right into how we're going to use them with COVID-19. For the first thing we're going to start with is a digital twin model. So what in the world is that? You're defining a class or a type of entity, whether that's a machine, a car, a person, whatever. And so what I mean by that is, instead of identifying attributes for me personally and my wife and my kids and everybody in the world over and over and over and over again, let's just define it one time. Let's just create that. If you're an object-oriented programmer, maybe you're not. You might think of a base class where you define a lot of the properties, attributes, and then you inherit from that with the instance of an object, right? Pretty geeky stuff. Same kind of thinking here, though. I'm going to define it once. Like if I talk about my car, if I've got a Volvo XC60 2016 and it's all-wheel drive, you get to define it, all the attributes for that model, and then the instances of that model are all the thousands, tens of thousands of XC60s that people actually bought and own. and they inherit those attributes from the base class, from the primary one. So that's kind of the thinking there. So it really saves you time. You just define everything once and then inherit to everything else. Baseline information could just be really simple stuff. What's the name, description, probably a version number of the twin model, because things could change over time. So you might want to version it, have different versions that might have different attributes in new ones that you could use. Probably need to have a picture of what you're talking about. People are doing really, really advanced stuff with digital twins, are, especially in that PLM space. We'll do 3D CAD models of stuff. I've seen the most advanced stuff you can imagine around digital twins. I've seen these cool 3D CAD models of container ships, and you see every compartment, and it's super intricate. It's really powerful stuff. Just know, though, that you don't have to do all that to get the power of digital twins. It's like turning the volume on your stereo from 0 to 10, maybe 11. Just turn it as much as you need. Use as much as you need. There's always tons of value to gain from digital twins. You don't have to go crazy there. So I'm going to define all the aspects of that type of thing one time instead of repeatedly over and over for each individual thing. And each instance is going to inherit that, right? All right, so that's your model. So let's kind of move on. So static properties, what in the world's that? It's basically values, properties that don't change very much, or at all. They're just kind of stay the same. So it's not dynamic stuff that's coming in. So if we stick with the car metaphor, how long is the car? It's 20 feet long, it's got 6 cylinders in the engine. It's got so many cubic square feet in the trunk, all kinds of attributes, that don't change. Maybe I'm talking about a windmill turbine generating electricity. It's certain height. It can bend so far when wind blows against it without having structural problems. All kinds of stuff like that. This is all super important. It's not dynamic, but you will reference dynamic stuff with static stuff and analytics to make decisions. Anyway, in the end, it gives you a complete view of whatever that entity is, a machine, a person, a thing, whatever. So let's dive into some static properties for a person with our COVID-19 issue, right? Because the person's going to be the twin, and and everything I talk about is going to require opt-in privacy. I'll just kind of preface this in advance. Some of the things I will talk about, you may raise red flags and say, Rob, this is crazy. This is a privacy problem. This is a GDPR problem. I totally get it. This is just high-level ideas. When you brainstorm, there's no bad ideas. We just want to get them out on the table. We'll resolve issues as we come to them. So I'm going to come in advance and say, yes, there are potential privacy issues. Countries who are doing similar types of things, they're doing lots of opt-in. But we'll see. Anyway, it's stuff to figure out. But the idea is where you need to start, and then we'll figure out the problems later. Some of these things won't seem too crazy. So here's just easy stuff, static stuff: first name, last name, age. As you've seen in COVID-19, you've noticed that, older people seem to be having more problems than younger people. It's not absolute, but the reason you want to age is because that you want to because ultimately we're trying to get data, and we're going to slice and dice stuff. And so it's for demographics. So you want that age. And then lots of just yes, no, Boolean, yes, no, 1 or 0 type questions, kind of check boxes. Underlying issues. Do I already have underlying issues? Do I have problems with my heart or my lungs already? Am I a smoker? Do I have a compromised immune system? Things like that. We want to know that. And my biology, that helps. That's part of the demographics to see, because in some places we're seeing that more men are being affected by this than women. And so this is more about demographics as well. Home location. I know this is a super privacy problem. Could be just a GPS coordinate, could be an address, but it's basically your home base. Because as we start to, I'll talk about this later, you're going to want to start mapping things out. Where do you live? Where are you at home at? Because we're going to start carving out regions and areas, just like you've seen on the news, when you've seen maps of your country and stuff like that, or the world, and where the hotspots are. That's why you need this location data. Also work location. I know a lot of us are working from home. Some people are still having to go to the office, or maybe they're in a factory. It just depends. A lot of things are pretty shut down though right now, but this will help us as we go into the future. Where do I live? What's that cluster, that area look like? Where does my work look like? Because we need to know what things are looking like in these 2 areas, because that's kind of where you hang out the most, right? So telemetry properties. This is dynamic stuff. This is stuff that's flowing in. So when I think of IoT and machines, And devices, I think at telemetry, it's data coming from sensors, the temperature sensor, humidity, accelerometer, all kinds of kind of analog type sensors. In this case, though, it could be manual. People type it in and send that data, data is data, right? And so whether it's fully automated like a cool IoT system or whether it's people doing it manually, I don't care. This is all hands on deck. So let's get that data. So that telemetry, those properties that you define for the digital twin, you probably have an event processing engine. Like if you're using an IoT platform, data comes in and an event fires. And that's a moment where some kind of engine can look at that data and analyze it and make decisions right in that moment. A lot of times you might think of time series data and streaming analytics, that kind of thing. To help this analytics, you need to provide some great metadata to assist it, right? And so data labels. So all those properties I talked about, like if it was a temperature or humidity or whatever, you need to give those labels. So the analytics, because data might come in and the data that might be for a sensor might just be the number 91 or 5 or whatever. The analytics doesn't know what to make of that. So you got to help it. Give it a label, tell it the data type. The data coming at you is an integer, that's a whole number. Or maybe it's floating point, maybe it has decimals, maybe it's a GPS coordinate, maybe it's text. Doing that helps your analytics more easily know how to deal with the data. And then things like units of measure. What is the context of this? I know the data type's an integer, it's a whole number, and then the label might be temperature, but I don't know that. So the unit of measurement might be temperature, Fahrenheit or Celsius, might be, motion, might be all kinds of things, pressure. So those kind of three things help your analytics understand what's coming at it so it can work with it appropriately, gives it context. Without context, it's just the data doesn't make any sense, right? So let's talk about some telemetry properties. This is not necessarily an exhaustive list that a person who's opt-in with privacy may be sending to in this case, I'm kind of talking about the Moab platform, this free platform that could collect this data and analyze it, right? But it could be other platforms, right? This is all basic stuff. Just about any IoT platform can deal with this. So you may have heard about losing your sense of taste or sense of smell. From some doctors you've seen on TV about this. And so, a lot of these will just be kind of these Boolean data types, just 1 or 0, yes or no. Have I lost my sense of smell or taste? So answering that question and sending it. Am I having trouble breathing? You've heard about people saying it feels like they have a ton of bricks on their chest or something like that. The breathing's just really labored. Yes or no, do I have that? Extreme fatigue. I don't know about you, but hear about people when they say that it's hit them so hard that just walking from their bedroom to the bathroom, it completely exhausts them. So that level of fatigue, I keep hearing about that a lot, Everything's been different though. Some people don't seem to have any symptoms at all. And some people have the roughest 2 or 3 weeks of their life. You hear about the dry cough over and over again. Not just a casual dry cough from time to time, the kind where you're coughing so much, your ribs are hurting, your chest is hurting, maybe even hard for you to breathe, catching your breath because you're coughing so much. So that kind of stuff. Because we know that COVID, it starts messing with your lungs in a big way and putting a nice coating over them. And so it's really difficult to get oxygen. And you're obviously you have a reaction to try to cough that stuff out of there. Temperature has been a big one. So temperature, a floating point data type, that just means it's got a decimal. It's not a whole number, Fahrenheit or Celsius. So you've heard about that magic number. At least in Fahrenheit, it's 100.4 degrees. You see in many countries, they use those kind of thermal scanners. They aim it at your forehead. You don't get on the train until we scan it. I don't let you in this office building until I scan you. You don't get into the elevator until I scan you. Countries who are really on top of things are doing stuff like this. This is super important, but not every country is doing it. This is an easy early measure of knowing what's going on. Taking the test itself. Did I take the test? And so in this case, I'm just going to use an integer, and it's not a Boolean because I've got 3 things to choose from. So 0 means I haven't been tested at all. Maybe I don't have any symptoms, if I have been tested and I'm positive, we're going to say 1. If I've tested and I'm negative, I'm going to say 2. This is the most concrete information we have. But remember, depending on where you are, testing has not been that great. Some places are really on it with testing. Some people are just testing sick people. Some places are struggling to test at all. It just depends on test kits and getting things out there and how long it takes for results to come back. It's also a people issue, getting personnel to the right location. Timestamps, all this stuff coming in. When did it happen? Again, we talk about time series analytics. It's all based on time, so that I can see not only what the latest state of things are, but the historical state, so I can do trend lines and see what's going on. Just stuff you've probably seen on TV when you've been watching the news. Current location. So I talked about home location, work location, but where are you right now when you do this test? Maybe you're somewhere in between. Maybe you're at a store. Maybe you're at a restaurant, going through the drive-through, I hope, or doing a pickup, knowing where that is. Because again, mapping and where all this stuff is super critical, while totally getting about the privacy issues. And then speaking of crazy privacy issues, this idea, you've heard of the term contact tracing. Basically knowing and trying to discover through detective work, once they found that you're positive, who are the people you've come in contact with? So you've heard about social distancing. You've heard about trying to be a couple meters away, 6 feet away. If it turns out you were positive, people want to find out who have you had contact with, because we need to know where it's potentially spread. Again, data is your helper. Flying blind is the enemy. So a lot of places are having to do detective work, trying to have you remember, who did I come in contact with over the last 14 days or whatever? And of course, then you can imagine it goes from there. Who have they been in contact with? And this is how you try to figure out the spread, but it's also how we try to contain it. So knowing the digital IDs of the twins of the people who you've been near in the past, in the event that you have tested positive, or vice versa, someone else has tested positive, and they need to know if they came in contact with you unknowingly. A lot of times you're just kind of a passerby, or you're talking to someone or whatever. You've heard about coughing, sneezing, that distance, but I've also heard from other experts, being in a confined room, or there maybe, you hear about asymptomatic people who, they're not coughing and sneezing yet. They feel fine. But I've heard of scenarios where you've been in a close quarters and maybe just talking, breathing near someone for 15, 30 minutes. If you're close enough, there's been instances where asymptomatic people are transmitting. And that's the scariest part of this whole deal, is people who seem fine might be causing the most spread, right? Because they don't know there's a problem. So we need to know who all these other people are, but we need to do it in a totally opt-in, privacy, official way, all in with GDPR, right? So rules and actions. Now that I've got this data, what am I going to do about it, right? This is simple stuff. IFTTT, if this, then that. I don't know if you've ever heard of that. There's a website, you can trigger in actions, people do it like for stock prices and all kinds of things. But basically what it means is, if this, then that. If this equals a certain thing, then do that, right? So we're not going to do any crazy machine learning or calculus or advanced linear algebra or deep learning, random forests, any of that crazy stuff. We don't need a neural network to figure this stuff out. We're just going to do simple if this, then that, and we're going to just focus on KPIs, key performance indicators. You may have worked with those at your company. Green is good, yellow, it's like, kind of getting weird, and red's bad, right? And then what's the prescriptive action we want you to take based on that? So what is it? What's the meaning of it? What do I want you to do about it, right? This is the power of IoT and analytics. That's why people want to do this stuff. All right, well, we're going to do it here. So I'm going to walk you through, and we're going to geek out just for a second. I'm going to take some of those dynamic properties that I showed you earlier, and I'm going to just apply some simple rule stuff. I'm not going to do all of them, but I'll give you the gist of it. So you can imagine here, once I have that data that comes in from you, sense of smell, or, that's that geeky programmer way of saying or. So if the sense of smell or taste is false, like I've lost them, then what do I need to do about it? You probably need to isolate right away. You need to contact your doctor, and you need to get a test. And I'm going to put you in the yellow KPI. I'm not necessarily putting you in the red KPI because I don't know for sure, but we're close. If you've lost those things, that's a pretty strong indicator. But it's not the same as the test that tells you yes or no definitively. So it's clearly not green. We don't know for sure if it's red. So we're going to put you in the yellow zone for this one. And you'll find a lot of these might be in the yellow zone. And of course, this is subject to temptation. This is just my quick opinion as I'm throwing this together. There's people smarter than I am that can better define whether this should be green, yellow, or red. That trouble breathing or extreme fatigue, if you're having that, yeah, let's isolate you, contact your doctor and let's do a test. And you're probably in the yellow zone. That dry cough, if it's just every once in a while, you're probably just green. But if it's happening a lot, you need to stay isolated. You need to take a test, and you're in the yellow zone, right? Temperature. If you're one of those countries that's still using Fahrenheit, then if it's greater or equal to 100.4, yeah, you need to get isolated. You need to reach out to your doctor. You need to get a test. So you're in the yellow zone, but these are all kind of indicators that that you could be infected, but you don't know for sure, right? If test is equal to 1, in other words, I've taken the test and I've tested positive, quickly isolate, contact your doctor. You may or may not have to go to the hospital, right? As you've heard lots of doctors talk to you on the TV, over the last several weeks and months, early days, they're just saying, stay at home if you're doing okay. But if you get to that point where you're really struggling to breathe, your oxygen levels are low and you're just, because your lungs are getting all coated up and you can't get O2 oxygen in there, then you might need to go to the hospital. But always contact them in advance. They don't want people just showing up. We don't want potentially infected people just walking into a physician's office or whatever. There's a procedure to follow because we need to keep everybody safe. This is also the time when we need to contact and find out who these other people are that you may have been in contact with. So this is clearly the red zone. If test is equal to 2, like you're not positive, you're negative, you're good to go, then you're green. Maybe you could go to work. I know things are fluid right now and what work is weird. But in the future, when we talk about putting people back to work and getting the economy going again, we'll need this data to safely do that. We're not going to just do it. We have to safely do it. So this is an idea of some of the simple tests. There could be a lot more. I just wanted to put a few here on the screen to get going. So containment versus mitigation. What do I mean by that? We want to contain the virus. And that comes from lots of data, early data, testing data, things like that, test. And the countries who've done a good job of containing to keep it from being an uncontrolled spread have had that data early on, versus other places where the virus has just started to spread uncontrollably. They didn't have data, or it's been reactive data. I'd say most cases it's been reactive data. And what I mean by that is you didn't know anything until you finally tested someone and they were positive or negative. We know that a great many more people may be infected that have been tested because we just haven't either had the test kits, the personnel, the time, whatever the reason may be. And so you're backpedaling, you're on your heels trying to mitigate things. So I'm all about helping to contain this. And that happens from fast data, frequent data too. So you as a person have now become the physical IoT device. But you're not a machine. Well, you kind of are, maybe. But you got to send your telemetry data, but you aren't necessarily software and sending something, but you have a helper. There is something that just about everybody in the world has. I'm in the cellular business and I've seen the stats, and it turns out we have more smartphones on this planet than we have people. So high saturation. So lots of people have smartphones, and you don't have to have an iPhone or the most expensive, Galaxy or different device to do this. The lowest cost Android phones are just fine. Stuff that anybody can have, stuff that we could give away. Talking about giving things away, personal experience, if you think about education, my wife's a school teacher, and so lots of school districts, either some school districts are open, kids are going to school, others are completely locked down, some are doing over the web instruction. But you have some kids, some families who maybe don't have internet access. And so they've been maybe giving those families internet hotspots, like the thing where you have it looks like a little hockey puck that maybe gives you LTE, 4G connectivity, and then turns into Wi-Fi so that your laptop or tablets can connect to it so that you can get that education. So we're already seeing that happen. So there's things like that. You're seeing school districts giving low-cost laptops or tablets to their students. So that's kind of the thinking here. So this is just analogous to that, but it's with this COVID thing, right? So smartphones and apps is how you become an IoT device and endpoint and get that data to the digital twin of you so we can analyze it, right? So I'm going to have you send that data multiple times a day, just like we do in the IoT world. Machines, it's not enough that one and done is not it. You know, some machines need data every second, some every hour. Frequency depends on what the situation is. It's important to have fresh data about you, all those things that I showed you through, all the check boxes. You know, if you look to the right here on the screen, you see I've got an Android app that I built, which is the simplest app you can imagine, right? You know, all that information, the static information. Yeah, right, I'm 25. And then those just check boxes. Do I have this underlying issue? What's my temperature? And you can imagine if you scroll down or if you had different pages on your app, all that other data would come in. And so it's important to, even once you're tested and you're green, remember, you don't just stay green. You could become red again later, depending on where you travel. If you come out of your green zone into a red zone, you could get infected again, right? That's why they say, even though we think we beat this, which who knows, you still have to be vigilant because it can pop back up again. We could go into the summertime in the Northern Hemisphere and it could get really warm, or we could have heat waves and it may seem like the virus has gone away. The heat just zapped it, but it doesn't mean it won't come roaring back in the fall and winter, right? So vigilance and staying on top of these things. And so the frequent data, because your status may change over time. So several times a day, potentially, you know, my temperature is 98.6 right now, but gosh, what happens if late in the afternoon I go over 100.4? No bueno. All right. So fresh data. Again, I can't emphasize this enough. Opt in, following local privacy laws. When we talk about how do we get data from people who are around you. A cool feature of every smartphone on the planet, just about, is Bluetooth. Something that came from Ericsson a long time ago, given away. Just like the internet's given away and the web's given away, that makes it most pervasive and used by all people. So all these smartphones have Bluetooth usually. And there's something called Bluetooth Low Energy. And there's things, you know, where it can broadcast information to people around you. So unlike Wi-Fi, that's got a pretty long range, and then cellular, which is, you know, insanely long range, right? The whole earth potentially, right? But certainly around the cell tower. Bluetooth has a shorter range, but it's a great estimator for kind of nearby people, right? And so you can imagine your app using the Bluetooth in your phone to broadcast, because it can broadcast stuff out there to say, hey, here's my ID. So you can imagine a scenario. Let's just say, hypothetically, everybody on the planet had this app you see on the right-hand side of the screen here. And that app is not only broadcasting my unique identifier, which is secret, or it could be a combination, it could rotate IDs, everything, and only like governmental agencies or the right, you know, privacy approved agencies know what this all means. So I'm broadcasting, but also people around me with the same app, they're all broadcasting as they walk by me, you know, we're walking down the street or whatever. So they're broadcasting. I'm capturing who they are, their secret IDs in my app, storing it locally. Likewise, they're all capturing my ID in their app, storing it locally. You never see it as a person, what those IDs are. You don't even know what they mean. They're secret. And in the event, based on the person in the app, when you say, yes, I'm infected, that's when the appropriate governmental agency or whoever will then be able to grab those secret IDs, find out what they really mean, and be able to reach out and contact those people to say, hey, you may have been exposed. Lots of privacy issues, lots of secrecy, lots of encryption stuff there, but seems like a great way to do it. It seems like it's a whole lot easier than getting on the phone and trying to do detective work with lots of people and calling people, because that's going to be less accurate. So anyway, that's kind of the thinking here. Mapping. As you can tell, I live in the Seattle area, Redmond, all that fun stuff. So I'm just kind of mapping, you know, like I said over and over again, you've seen lots of maps as we've gone through this whole thing, this journey. So knowing this information, knowing it proactively by people self-reporting, you know, everybody gets to be an IoT device. So everything that comes up red will maintain quarantine, and we will know how to position appropriate medical personnel, the right equipment, the testing equipment. You hear about getting ventilators, all the stuff you need to help people, and the right medicines as we evolve. I know we're going to be waiting maybe 18 months or so to get a real vaccine, because there's lots of testing and everything that has to go into that. But as we find other, medications that may help, and we don't know yet, there's lots of possibilities. You probably hear about them all the time. Anyway, instead of us blindly thinking that this whole state or this whole province or this whatever needs everything, it's better to actually know. And that's what the power of IoT is. It's the power, we're not guessing anymore, we're knowing. And so we will be able to identify discrete red zones of people or clusters of people, families and friends, things like that, or people who were contacted at work, or they were all together, at a church or wherever, right? Or at a concert, or they were on the beach. I know you've seen all this stuff on TV. Identify those red zones and then position personnel, equipment, medicines into those areas specifically, because we have data. We know, we're guessing. We're not guessing, we're knowing, okay? Knowing versus guessing. Then we talked about the yellow stuff, right? That kind of in between. I don't know for sure that you're positive, but boy, you sure got some symptoms that sound like you might be. So we'll use those yellow zones. Get those, you've seen people doing the testing swabs, sticking them up your nose. You've seen kind of drive-through things, where people are doing that. We can get those swabs to people in their homes, mail them to their homes. Once we know what yellow zones are and that identifiable people, because they've used this app, the appropriate government agency following all the privacy laws will say, you know what, it looks like based on the symptoms you self-reported that you may have it. I'm going to mail you a testing swab that you can do yourself. And then you're going to put it in an envelope and mail it. And we're going to position rapid testing zones, nodes, if you will, into these areas. So not just all scattered everywhere, they're positioned where they need to be, close by. So it's same day. Think about the old days of Netflix before it was the ultimate, streaming service. Remember they used to just mail you DVDs? If we can mail DVDs, we can mail swabs and get them tested. And you've probably seen great advances in testing. I think there's some new machines out that can test and know in about 5 minutes, which is incredible. So if we move those into areas where you could do same day testing, maybe either drop something off, mail it, whatever it is, as opposed to waiting. And I've seen some insanely long lines of cars waiting to do the drive-through testing. Anyway, stuff like that to identify things really quickly and get that real knowledge. And then green zones. We may find there's big blocks of green areas where no one's infected, no one's got those symptoms, and we have cautious optimism that those are safe zones where maybe people could go back to work if it's an in-person kind of work, right? Where they need to be on an assembly line or working on whatever. Can't work from home necessarily, that kind of job, right? So identify those green zones, because when we talk about, like I said earlier in the session here, we talk about putting people back to work, we got to be thoughtful about that and careful. And so this knowledge of green zones and will help us more safely put people back to work and fire up the economy again without causing new spikes, in the virus. And again, though, even though you're green, testing every day, self-reporting, sending that information every day, maybe multiple times a day, because that map and where all these red, green, yellow zones could be fluid. Obviously, the goal is to get everything green, but we'll never get there without data. So I hope this has been informative to you. Again, this is just my 2 cents of a way to use data, self-reporting data, actual test data, IoT. You are the thing, using your smartphone to send that telemetry data. You're going to send some crazy JSON file looking thing that you probably don't necessarily understand what the heck that is, and capture that, analyze it, and figure out mapping and how we're going to work with other people who may have been near you, how we're going to create these safe zones, yellow zones, red zones, things like that. Anyway, this is my idea how we could use this technology. This is how you could apply it to that Moab platform I talked about that I've built to give away, to help humanity. That's what it's all about. So anyway, I hope this has been helpful for you. I want everybody to stay safe. I hope you're having a good IoT day. And let's beat this thing. Let's beat this virus. Let's all work together. We can make it happen. Thanks a bunch.